So let me ask you a question. Have you ever wondered why some fluids flow smoothly while others seem to churn and swirl unpredictably? Well, the answer lies in a powerful concept from fluid dynamics. It's called the Reynolds number. And in today's experiment, we're going to show you how we bring this concept to life. We'll show you exactly how the Reynolds number helps us predict whether a flow is laminar, transitional, or turbulent. Using a simple setup, you yourself can even try at home or in a classroom. So stick around as we explore the science behind one of the most important dimensionless numbers in physics and watch fluid behavior change right before your eyes. In 1883, Osborne Reynolds, a British physicist, derived an equation that was able to predict the nature of a fluid's flow, specifically determining if that fluid is laminar or turbulent. That number equation is also known as the Reynolds number equation. You now may be asking, what does laminar and turbulent flow mean? Well, in simple terms, laminar flow is when a fluid like water is flowing smooth, with parallel layers of water moving without mixing. It would kind of look like you were staring at a piece of glass. While turbulent flow is when water would be chaotic, moving irregular with fluid particles mixing into each other. One more thing to note is that when solving the Reynolds number equation, you get a Reynolds number that represents the ratio of inertial forces to viscous forces in a fluid. Now that you know who Osborne Reynolds is and what his Reynolds number equation is meant to do, we can get down to how it works. The Reynolds number equation is made up of a top portion divided by the lower portion, which is the density of the fluid times the flow speed times the characteristic linear dimension, all being divided by the dynamic viscosity of the fluid. If the Reynolds number of the fluid is below 2100, then the flow would be laminar. If the Reynolds number is between 2100 and 4000, then the flow would be transitional, which is another way of saying a mix of laminar flow and turbulent flow. And finally, if the Reynolds number is above 4,000, then it is indeed turbulent. Now, onto the experiment. To recreate this project at home, all you need is some 3/8 inch tubing, a quarter-inch tubing, syringe and food coloring, paper clips, duct tape, 47 quart container, a 16 quart container, a 1.5 inch clear PVC vinyl tubing, a 1.5 inch PVC ball valve, a 1.5 PVC 90-degree elbow, some waterproof sealant or silicone, and a quarter-inch tubing valve. When gathering your materials, if you do decide to change your sizes, make sure the other parts go along with it. Be consistent. As you can see here in this photo, we have all of our material laid out on the table with the pipe, ball valve, and PVC elbow already attached to each other on the right. The apparatus is assembled with the clear pipe being attached to the container with the syringe inside the clear tubing. The syringe is attached to its own small tubing, which leads to another container with food coloring mixed into the water. This food coloring will give us a visualization of how the flow of water will act inside the clear tube. After you've done all of this, you will then place the container of food dye at a higher elevation to allow the water and the food dye to flow down into the syringe on its own. Now, all you need to do is fill up the big container with water, and then you can start your experiment. Now that you've seen what our laminar, transitional, and turbulent flow look like, let's talk about the numbers. We have recorded data for 5 tests, with 2 tests for laminar flow, 1 test for transitional flow, and the last 2 tests for turbulent flow.
Gathering data.
Thanks to my trusty robot assistant, the first laminar flow test came out to be a Reynolds number of 456.57, with a time of 1,552.02 to fill a 5-gallon bucket up with water. This is with a temperature of 77 degrees Fahrenheit. and it is indeed a laminar flow since the Reynolds number is below 2100. The second laminar flow test came out to be a Reynolds number of 440.46, with the time coming out to be 1608.8 seconds. This is also laminar since it is also below the 2100. The transitional flow test came out to be a Reynolds number of 2674.21, with a time of 264.98 seconds to fill up. Since the Reynolds number is between 2100 and 4000, it is indeed transitional. The first turbulent flow test came out to be a Reynolds number of 18,721.62, with a time to fill of 37.85 seconds. This flow is definitely turbulent due to the Reynolds number being larger than 4,000. And the last flow test came out to be a Reynolds number of 12,479.70, with a time to fill of 56.78. This is also a turbulent flow since the Reynolds number is bigger than 4,000. And that wraps up our look at the Reynolds experiment. We saw firsthand how the flow of fluids transitions from smooth and laminar to chaotic and turbulent. It all depends on that critical Reynolds number. Thanks for watching. I hope you enjoyed our video and learned something new today. Remember, stay curious and stay inspired.
Bloopers.